Sorry guys, I apologize for that interruption. One more time, what we're doing is we're checking the scale factor. We already know it's not a dilation because the orientation wasn't the same, but the scale factor, if I do A prime, B prime over AB, and I'm doing these ones because I can count them, right? They're both horizontal lines. So A prime, B prime is 1, 2, 3, is a length of 4. Whereas AB is also 1, 2, 3, a length of 4. And of course 4 divided by 4 is 1. So I get a scale factor of 1. But when I do the next one, right, I can also do B prime, C prime because it's a vertical line and I can count that. B prime, C prime over BC. Well, when I do this one, B prime to C prime is 1, 2, 3 over 1, 2, 3, 4. Well, now I've got a problem, right? 1 and 3/4 are not the same. So because I do not have a common scale factor, remember the ratio of the sides has to be the same. They have to be the same. And if you get a different ratio for corresponding sides, not a dilation. So no common scale factor and not a dilation. It just is not a dilation. All right, now the last thing I want to talk about with you guys, I mentioned it on the first page of the notes, and then I told you we would come back to it. And it's simply this: determine the center determine the center of the dilation. Okay, so I got a couple of problems for you here on the next page, but essentially it's this: when we have a figure and its image after the dilation, what you're going to do is that the center of dilation, you can find the center of dilation by drawing lines that connect corresponding vertices. That's really sort of the part that I want you to take away from this. Find center of dilation by drawing lines that connect corresponding vertices. And like I said, I got example problems on the next page. You'll see exactly how this works. It's not too terribly tricky. So here we go. I got two problems for you here. What I want you to do is find the center of dilation, and we'll also, at the same time, get a little bit more practice here, we'll find that scale factor. Now, again, you would need a ruler in order to measure those, but I'll just give them to you for now. The point is simply this. I did one for you, then we'll do one together. I've given you two triangles. The way you find that center of dilation is by what I just highlighted, connecting corresponding vertices. So C and C prime go together. I will draw a straight line through C prime and C. Okay, then A prime and A, corresponding vertices, draw a line through A prime and A, right? And then B and B prime, corresponding vertices, draw a straight line through those guys. And what we're saying or telling you is this: the point of concurrency is the center of dilation. Remember, point of concurrency, we talked about that back when we were doing triangles with altitudes, medians, angle bisectors, perpendicular bisectors, right? A point of concurrency was the point where all of those lines intersected. So point of concurrency is the center of dilation. It is the center of dilation. So there's my center of dilation. In fact, in this case, I called that point O. Now, another way, since I don't have the lengths of the sides, it's actually kind of interesting. Another way that you could do this is by measuring the distance from the center of dilation to each of the vertices and doing that ratio then as well. By setting up those ratios, you actually will get the exact same answer. So what we did in previous problems was we simply took, right, the ratio of corresponding sides, right? So I would do AB divided by A prime B prime, or vice versa, A prime B prime divided by AB, right? The ratio, the lengths of the sides. It turns out I can get the exact same answer by taking the length from O to B, and dividing that by the length from O to B prime. Now again, you would need a ruler or some sort of straight edge to measure these, so I'll just give you those measurements. If the distance from O to A is 25, so from my center of dilation to the point A, we say it's 25, I don't know, inches, centimeters, whatever. O to B is 13, and O to C is 19, right? So that's the distance from my center of dilation to this first triangle right here. O to A, 25, O to B, 13, and O to C, 19. All right, now let's do it to the next triangle. So O to A prime, that's going to be 50. O to B prime, 26. And O to C prime, 38. And again, I don't think you have to look at those numbers too hard to see. You can figure out what that ratio is going to be. Here we go. We're going to do OA prime over OA, which is 50 divided by 25, which comes out to be 2. Then we're going to do OB prime divided by OB, right? We're finding that ratio, which is 26 over 13. Look at that. It comes out to be 2. OC prime over OC, 38 over 19, and cuckoo cuckoo comes out to be 2. Right? So a couple of ways actually to find that scale factor. You could set up the ratio of corresponding sides. Or if you know the center of dilation, measuring the distance from that center of dilation to corresponding vertices and setting up those ratios actually gets you the exact same thing. I got one more for you here for you to try on your own. I'll simply give you the links and then let you do it. I've given you sort of a similar setup here. 2 triangles. I've already drawn the blue lines for you, so there's our center of dilation right there, point O. Let me give you these, and then I'll let you go at it on your own. OA is 60. OB is 38. And OC is 52. OA prime is 30. OB prime is 19. And OC prime is 26. Again, all I did, just get yourself a ruler or something like that. You wind up with the exact same thing that I got. And anyway, the point is this. Go ahead and set up your ratios and see if you can figure out the scale factor. Hint, scale factor is going to come out to be 1/2. Check to make sure that that is what you get. If you don't wind up getting 1/2, go back, look for mistakes, something like that. Make sure you set them up in the right order. OA prime divided by OA, and you should be all set. Guys, that is just, again, a quick, brief introduction here to dilations, which we will be spending this entire chapter talking about dilations, the way they work, and actually calculating things like scale factor and center of dilation, as well as talking about all those properties again. It maintains shape, it maintains betweenness, collinearity, and orientation, right? So all really important things about dilation. Had a great time going over this with you, and I'll see you next time.